Let's solve the following physics question. So the first question is define torque of a couple and state its SI unit. So that's the first question. Let's go ahead and solve. So torque. So the torque of a couple, is the turning effect. The turning effect produced by two equal and opposite forces, applied two equal and opposite forces that are in parallel, from the line of action. So you might have an object here. So you have a force F1 and you have another force here F2, and F1 is equal to F2. So they are parallel. You can see that the distance between them is maintained and they are in opposite direction, so they will produce a turning effect. So let's go on to the next question. Fig 3.1 shows a uniform wooden board of mass 3 kg and length 40 centimeters used as a bookshelf. The board is supported by a light string. So the board is supported by a light string from end A to the wall at an angle 36 degrees. So this is the angle 36 degrees. Two books of mass 1.5 kg each are placed such that their center of mass is 25 centimeters from the hinge. So we're going to first find the weight of the books of the board. Let's find the weight of the board. Firstly, let's calculate the weight of the board. So the mass of the board, F, weight of the board F is equals to mass multiplied by acceleration due to gravity. So it's going to be mass multiplied by acceleration due to gravity. So that's 3.0 multiplied by 9.8. This is going to be equal to 29.4 newtons. So we're going to calculate the weight of the books. So these are two books each. Each with a weight of 1.5. So mass is going to be 1.5 plus 1.5 multiplied by 9.8. This is going to be equal to 29.4. So after I've calculated like this, I'm going to draw my diagram. But before I draw my diagram, I need to make my conversions pertaining to the distances. So the weight of books here, is acting at 20. It's acting at 0.2 meters. Remember that the books are placed such that the center of mass is 25 centimeters from the hinge. So the weight of books is supposed to be 25 here. And the weight of the board, center of mass of the board, is 40 centimeters. So half of 40 centimeters, that's 20. So you're going to have 0.2 meters. So let's draw a diagram of this information. So our diagram here, it's a wall. We're going to have a wall. then you have a hinge here, then a board, then a string. You have a string touching the board here. So books are going to be here, and their center of mass is going to be 29.4. So here, center of the board is going to be 29.4. So here there is tension T. So the component of tension that goes in this direction is T sine 36, since this is the angle here. So let's go on and put on the distances. Let's put on the distances. So for the center of mass from here to the board, here to the center of the board, that's 20. So my diagram is not to scale. So this one is 25. It's not to scale the diagram. So the calculation is important. So let's move on. Clockwise moments. Are equal to anti-clockwise moments. So T is it T sine 36 multiplied by 0.4. So this one is acting at the maximum. The distance here is 0.4. That's the length of the board. Is equals to, so 29.4 for the books multiplied by 0.2, then plus 29.4 multiplied by 0.25. So you have this. So you're going to have T. You solve this one and you're going to get T multiplied by 0.2351 is equals to 13.23. So your tension is going to be equal to 13.23 divided by 0.235. So 2351. So your tension is going to be equal to 56.3 newtons. So your tension is going to be equal to 56.3 newtons. That's the tension on the rope. So let's move on to the next question. You've calculated the tension in the string. Let's calculate the force exerted by the hinge. The force exerted by the hinge. So let's draw a diagram here. So this is the wall. You have the wall right here, and you have your board. This is the board, and this is the string, and this is the hinge. So the string, the tension is going to put a force here. So the hinge will oppose according to Newton's law. Every force has an opposite and equal reaction, and there is a downward force to the board. So the hinge is going to oppose that downward force. Yeah. So the hinge is opposing these two forces. So let's say this is hinge force in the x component and hinge force in the y component. So let's try and solve the hinge force in the y component. So you have the tension here. So here you have weight for books and weight for board. So you just say hy plus t. So this is t sine 36. is going to be equal to WB plus WBK. So we substitute into the formula is equals to 29.4 plus 29.4 here minus 56.3 multiplied by 0.587. So HY is going to be equal to 25.7 newtons upwards. So let's find the one in the horizontal. So the one in the horizontal, Hx. So Hx is only the component of tension in the y direction. So Hx is going to be equal to T cos 36, which is going to be 56.3 multiplied by 0.8090. So this is going to be 45.5 newtons. So according to Pythagoras theorem, our h is going to be equal to the square root of hx squared plus hy squared. So this is equal to 45.5 squared plus 25.7 squared. So our h is equal to 52.3 newtons. So we have found the magnitude of the force. We need to find the direction. So we are going to say tan minus 1 of 25.7 over 45.5. So this is going to be 29.5 degrees. So we have found the magnitude and direction of the hinge force.